see the setting. So it's going to be a problem. Come on. There we go. Okay. So as we start any problem, we read it and we see what we know about it and we try to formulate something from it. That's how it works all the time. So from the top, the functions f and g are differentiable. Okay? What does that mean? Tell me something that means. We know nothing. Make me cry. Okay, because of the fact that they're both differentiable, it means that both functions are continuous. There's no holes, asymptotes, jumps, anything like that. Vertical asymptotes, that is. Okay, what else?
For every x, we can find the derivative.
Correct. For every single x on both of these functions, we can find a value, a number, which is the slope of the line tangent. That means we can find the derivative at every single point. Okay? That's what it means to be differentiable. So in essence, both of these are smooth curves with no cusps or anything like that. All right, one down. And we don't know what they look like though, right? Okay. Second thing is for all x, f of g of x is equal to x, and g of f of x is equal to x. What does that mean? F of g of x is equal to x, g of f of x is equal to x. You may remember that from next year. Anya and Mary? So you guys discussing?
Anya thinks that I'm going to look into it. Just throw Anya under the bus.
Do they equal each other? Are they the same function? Like if one is x squared, is the other one x squared? Good idea. Okay. Anybody? What?
They're inverses?
They're inverses. Okay? That's the winner. So let's identify it. So we're going to make a little note here. F and G are inverses. That's what this means. Somebody ask it. Why? Exactly. Okay? Because we don't just take things as a given, we have to understand what it means. So I'm going to explain that using stuff up here. So let's take a look at the picture. I have to lead this thing. Okay. So I'm going to get rid of a bunch of these things here and leave just those. Okay? So look at these two functions. Okay? One is the blue one is the natural log of x, and the red one is e to the x. Okay? Have we ever been told that those two are inverses? Yes, we have been. What's the deal with an invert, with inverse functions, with two functions that are inverses? Yeah.
You switch the x and the
The x and the y are switched. So I'm going to try to demonstrate that. see the x and the y's? You see how they're switched? And watch this. No matter where I go, the x's and the y's are swapped. So in fact, when you were given a function and you were told last year in pre-calc to find the inverse of this function, the first thing you did was you switched the x's and the y's, and then you solved for the y, and that's how you found the other function. Okay, so these two functions are inverse functions because their x's and their y's are swapped. Okay, there's also another interesting little thing about this, and that is this is the line y equals x. Okay, this is the line y equals 1x. Okay, is there anything interesting that the two functions are related using the line y equals x? Pardon me? Yeah, exactly. Each of them are reflections of the other over the line y equals x. So y equals x is the line of symmetry. You could fold one right over the top of the other, and they would match up perfectly. Okay? So, I can tell you that these two functions are inverses. Okay, and I can say, just look at the picture. You can tell that they're inverses, because this is what inverses do. But I haven't really proven anything. Okay? What I need to prove is whether or not, if we do a composite of one and the other, we get an answer of x. And then if we flip them, we still get x for the answer. So, let's try that. So what I'm going to do is I'm going to take these two functions and I'm going to try to figure out how we can prove that they're inverses based upon that definition of that f of g of x. So I'm going to say, let's let f of x equal the natural log of x, and let g of x equal e to the x. Okay? So we're defining those two. And so the first thing I want to do is find what is f of g of x. What is f of g of x? Well, let's just do it, right? This means we take the g function and we plug it into the x, into the f function. So it's going to be the natural log of e to the x. Did I do that right? The g function is the e to the x. It goes in place of that. This is a composite function. All right, can we clean this up in any way? We know anything about logs? Natural log of e to the x. I seem to remember a rule. You can take that exponent, you can bring it down. Okay? Okay, so we move on. What's the natural log of e? 1. So therefore, f of g of x is equal to x. Okay? 1 down, 1 to go. Okay. So the second one is, what is g of f of x? What is that equal to? What is g of f of x? Okay, we're gonna do the same thing. So this one gives me e to the natural log of x. E to the natural log of x. Okay. All right, this one was easy, right? Just use that rule. So how can we prove this? Well, let me show you how we can do this. Let's suppose we don't know what the answer is. We just know that e to the natural log of x is equal to some number. I don't know what it is. Okay? I'm going to do a proof of what e to the natural log of x is. So, if I just say I don't know what it is, but I'm going to work with it, I can set it equal to this. So now what I'm going to do is I'm going to take the natural log of both sides. Totally legal to do this. Take the natural log of the left side and the natural log of the right side. Okay, right side, can't do much with that. Left side though, what can we do? Take a little clue from the last one. Convert this one down, right? So this becomes the natural log of x multiplied by the natural log of e is equal to the natural log of n. So, well, wait a second. Natural log of e, 1. So this means the natural log of x is equal to the natural log of n. Now wait a second. If the natural log of x is equal to the natural log of n, that must mean n equals x, or x equals n. So I can say x equals n. And why does that complete the proof? Well, remember this? We said that e to the natural log of x was equal to n, but n is equal to x, so therefore e to the natural log of x is equal to x, which proves g of f of x equals x. Got it? Okay, now the whole point, what we just did, was just to prove to you that when you learn this thing that f of g of x is equal to x, and g of f of x equals x, that means that f and g are inverses. Okay, we just proved it with two functions that we know are inverses. Okay, so 2 down, where do we go from here? The next one says if f of 3 is equal to 8 and f prime of 3 is equal to 9. Okay, we can do this. So f of 3 equals 8. 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8. That means for the f function, if you plug in a 3, you get an 8. That's this part. Okay, f prime of 3 is equal to 9. What does that mean? F prime of 3 equals 9. What does that mean? We had one like this in Proverbs that f prime of 2 was equal to 5. The slope of the line tangent to f at x equals 3 is equal to 9. So I can write it like this. I'll draw kind of a steep one here. Okay. The slope of the line tangent to the curve of f is 9. So I can say m equals 9. All right. So with all of this information, I want to know two things. I want to know what f of g of 8 is, and I want to know what g prime of 8 is. I'm tired of doing all of it. I can tell you guys have been swivelized. It's the quietest you've ever been. Tell me something that's going to help us here. Yes?
We know our slope when we have a point.
We know our slope if we have a point.
No, we know our slope, but do we have a point?
Do we have a point? Well, the question is, do we know g of 8? Yes. Yeah.
No,
What do you-
I'm just saying yes.
Yes, we have g of 8. Do we have an answer?
Yes.
What is it?
Oh, do I have the enter of the line?
G of 8.
Never mind.
It's 3. That's correct. Okay. Now, did we say that G and F were inverses?
Yes.
So if f of 3 is equal to 8, that must mean that g of 8 equals 3. Okay? So 1, 2, 3, 4, 5, 6, 7, 8. And here's a 3. This one is where g exists. You understand what I'm saying?
Yeah.
This fits now what I was talking about there. This point is g of 8 is equal to 3, and this one says f of 3 equals 8. In other words, this one's 3 comma 8, this one's 8 comma 3. That's what all that notation means. So, one down, one to go. We got our last thing. G of 8 is equal to 3. And now what's G prime of 8? Does that make sense? What we're asking here now is what is the slope of the line tangent at this point? Okay? And that's what we need to know. And that's now the discussion where we're going to go back to the front floor. Okay? So, let's see if we can figure out what the correct answer is to that by making an observation on the board. Okay, so I'm going to take these 2 points off of here so we don't have those. And we know that I can go along these points here. And what would be really helpful is if I had the tangent lines. So there's a tangent line for the natural log. See that? Okay. And then here's the tangent line for the other one. Okay. So, here's the question, is there a pattern that if you know the slope of the line tangent of one of the functions, then you automatically know the slope of the inverse at the point that is correlated with it? That's the question. Is there a connection between these two? It's kind of fun. Watch this. If if I stop it right at 1, what do you notice? They're parallel. That's the only moment that they don't touch. But if I let it just go, look at how they intersect. And they seem to crisscross, see, right on the line y equals x, which is kind of cool. And no matter how far I go up, they travel right along the intersect right here. So I want to know, what's the connection between the green line and the purple line? They're slopes. Say it again. Opposite reciprocal. Okay, let's take that one at a time. What would opposite mean? If one's positive, then the other one's negative. Okay, look at these. Are they opposites of each other? Look at those two lines, the green line and the purple line. Is one negative and one positive? No. They're both positive. Okay? So we're going to take away the opposite side. What was the other part you said? Reciprocal. So that would mean that if one was 2, the other one's a half. One was 4, the other one's 1/4. So on and so on and so on. Right? Okay, I wonder if there's a way that we can test that. I don't know. Other than maybe if we somehow had the slopes for each. Okay. If we had the slopes for each. Then maybe we could do this. Now the slope of the e to the x is the e to the x, remember? That's the red one. The slope of the e to the x is e to the x. So that's why these are always the same. But the slopes for the natural log are 1/x. 1/x. So I don't know. What's the reciprocal of 2.32? Pull out your calculator and take 1 divided by 2.32. What's the reciprocal of 2.32? Is it 0.43? It is? Okay, let's try another one. What's the reciprocal of 2.5? Okay, so what we have here is that if you look at the slope of the line tangent of 2 inverse functions, the slope of one is the reciprocal of the other. Okay, so that means going to the backboard and answering the question, what is g prime of 8? 1/9, correct. So the slope here was 9. The slope here is 1/9. They're reciprocals of each other. Okay. All right. This was actually a question on the EP exam.
Really? Nice.
What kind of question?
It's multiple choice.
It looks so difficult, and then you're like,
wow.
So if you come across one like this on the exam, you just have to recognize, oh, it's an inverse function. Do a quick sketch, and then see where that takes you to be able to do it. So I'm gonna give you another one right now. We're gonna do a second one. Smile for the camera. Okay. All right, here's a new one. Gotta bring the glasses out. So here's the question. It's a different kind of question, but it's still related. Let f be the function defined by f of x equals x cubed plus x. If f inverse of x, remember that notation, that -1, is equal to g of x, and g of 2 is equal to 1, what is the value of g prime of 2? Okay, now a problem like this, you got to do what we did there. Just kind of take it step by step, okay? I want you to digest it for a moment, okay? Read it, write down some stuff, try to figure it out, okay? And then we'll come back to it. So I'm going to let you take a stab at it first. You start to get to the point where you've got an answer, go back to the beginning and just double check it all. See if it should all match up, just like the picture up there matches. Okay, let's, anybody get an answer? What'd you get for an answer? Secret? Okay, let's figure out how we can get there then. I don't know, here's how I would do the problem. I'd say, all right, I know I've got some inverses going on here, and I know that g of 2 is equal to 1. That's probably the first thing I would do. Okay, I'd identify g of 2 is equal to 1. This statement right here says that f and g are inverses. Okay, f and g are inverses. So that means that f of 1 is equal to 2. So I know that. Here, f of 1 is equal to 2. So now I got my 2 points. Now, the question is asked, what's g prime of 2? So what I want to know is, I don't know what the slope is here, okay? But that's the question. What's g prime of 2? So all I need to do is find out what f prime of 1 is, and then take the reciprocal. So let's find f prime of 1. So here's f of x. So f prime of x is equal to 3x squared plus 1. That's the derivative of f. And f prime of 1 is equal to 3 plus 1, which is 4. So this means I know for sure that the slope here is 4. Therefore, the slope here must be 1/4. Final answer. Anybody get that right? Does this make sense? Okay, you see how I went about it. That's the key. When you draw the picture and you just take this what you have, put it together, it makes sense. Now, just so you know, this was a multiple choice. These were the distractors. Anybody get 1/13?
Yeah.
That's on here. Anybody get 7/4? No. 4? How about 13?
That's so mean.
All of those answers were the distractors here, where you felt like I got the answer right because I found it in the multiple choice, but it was wrong.
That's really mean. So they do it, but they say a little bit wrong every time.
They do a little, they
That's
make,
so
like, they do what they expect you to do wrong, and then that's.
That's actually makes me not confident that it makes sense.